So I promised myself I would work on some of the more grindy, sort of unpleasant things that you have to do from time to time just to make things work. And so I decided I was having some problems with performance on some of the levels, not on this one in particular. Oh, this is one thing I did. Is I have an in-game menu now. That's something else I did that's not really super fun. So if you look here at the Sokoban mini game, you'll see at the bottom right that the frame rate is, 30 frames a second, which isn't desirable. 60 is what we're going for the most part. And if you look at the bottom left, you'll see those collision checks. You'll see that we're doing 4,300 collision checks per frame. That's not good. And the reason this is I haven't done the math. I think it's a logarithmic thing where for every entity you add, you're logarithmically scaling the number of entities you have to check collisions against. And so when I first started writing it, I didn't really worry about collision performance. If you look at the algorithm I'm using, the naive version of the algorithm, you can see it right here. I kept it in the code just for this demonstration purpose. Basically, anytime something goes to check for a collision, is bounding box blocked, the old algorithm would just simply loop through every child of the dungeon and then run a bounding box overlap across it. And this was it's acceptable when you've got a small number of entities, but as I said earlier, as you increase the number of entities, you're scaling up, not just linearly, but like I said, I think it's logarithmically. You're scaling up the number of entities you have to check against. Like I said, I didn't really do the math. I just have a thing telling me, hey, that's a lot of checks, Pawpaw. So what I did was I used a partitioning algorithm. That's what if you look at these little boxes that are around everything, these boxes are kind of like the collision version of a printf is what I've got here. Now, these are not collision boxes. These are showing my partitioning algorithm. And what a partitioning algorithm is you find some sort of approach where you can break your world up into pieces. And then you put stuff in those broken up pieces. And you can imagine them being like little buckets of stuff. And then whenever you need to do a check of collisions, you only have to check against the other things that are in the same bucket with you. So for example, when I get up here, I'm now sharing a bucket, so to speak, with this portcullis. And so when there's a collision check, it's not active. I mean, it will. Right now it's not active. But when this algorithm is active, when you share, it only checks collisions on things that share these buckets, so to speak. And so you see this right here is just me debugging the algorithm that places an entity within these partitions. The way that I'm representing my partitions is, I've got essentially a grid-based universe. I've got 64 by 64 tiles. And so what I did is a very, very, very simple partitioning algorithm. I'll show you how it works right up here. Give me 1 second to find it. Okay, so right here. The first thing I do upon every click of the game is I erase my current hash. And then one time I loop through all my children and I have a hash function, a hash index function here. And what the hashing algorithm, the hash index function is very, very simple. I simply return the y coordinate times the math width plus x. And so what I'm basically doing is I'm projecting every entity into the specific, based on its x and y coordinate, the hash index where it belongs. And so things that, and what I'm doing is I'm taking all four corners of the bounding box of the entity and I'm finding what, and that's what this is right here. I say get occupied tiles, which basically takes the bounding box of the entity and figures out what 4 XY tiles this child occupies. Not 4, it actually gets all 4 corners and loops through them, so it could be some number of them, which is why when you look at the Skull Mullet character, you'll see that his array of these hashes is much larger because his bounding box fills up a larger space. And so going back here, we basically create an array at that hash index of every tile that it occupies. We're adding the entity to that hash index, and then when it comes time to actually do a collision or check for collisions, we basically say, okay, rather than okay, I'm not going to show you the code. I can't find it. But I'm going to show you the result. So if I go into the main dungeon, you'll see here I've got 3,300 collision checks occurring. In the bottom right, you'll see that it's 40 frames a second. If I toggle my algorithm, now I'm doing 98 checks at 60 frames a second. So that's pretty much what I spent the bulk of yesterday and today working on. It's not glamorous, but it's the kind of thing you really have to do from time to time to keep your game functioning properly.